Hi and welcome to an introduction to SolidCAM Imachining. SolidCAM Imachining is a great way to rough out hard materials or even soft ones. You can see to start off with I want to rough out the outside of this block I've got. I've picked a 1/2 inch end mill and I want to finish the wall at the same time. The software itself is automatically picked out what is the outside of the part, and down to the Imachining technology will give us an optimal step down to use to allow us to remove material as quick as possible. As you can see, the toolpath is not what you're used to, with SolidCAM Imachining using a morphed spiral strategy to ensure that we get the same cutter angle at all times whilst running around the part. This again allows us to keep the tool load down, allows us to cut quicker, and then reducing your cycle times even further. Now the outside is completed, let's do the pockets inside. Again, this is really straightforward with a new iMachining operation. In iMachining, we can simply just pick faces, and this allows us to take that geometry. It doesn't matter whether it's a closed pocket or an open pocket, it will automatically find whether the tool can go outside of the part or not. As you can see here, I've got 3 pockets that do this. From here as well, we can go and check the faces we've selected, pick the tool, and then choose again if we would like to rough or to finish it. From here, let's go and calculate the toolpath, as we know that iMachining looks at the optimal step down that we could have for the tooling. As you can see here, it's automatically found where it can enter and where it can't, as well as using that morphed spiral strategy again to give us optimal cutting conditions. And as we go through in the simulation, we can see the tried and tested helix into the job and get into the root of the material as quick as possible, and then open it up with a morphed spiral. Only strain from that slightly when needed in the very sharp corners. Once we get to the open pockets as well, we can see that it employs a strategy of moting, again allowing to deal with thin walls simply and easily for you, all done automatically. So that's 2D iMachining done, so let's move to 3D iMachining. As you can see in this part, I've got a vise and a 3D part that needs machining. 3D iMachining is the same as 2D iMachining, with it being able to pick geometry automatically, and this time I've picked a 16mm end mill to cut from. I can select levels that I wish to, so in this case I don't want to take the whole stock out, I just want to go to a certain depth, which I've picked as 37mm, and then I can add an extra millimetre just to make sure I've cut everything that's needed. I can switch the step down to one that I automatically choose myself, or one that the software tells me, and I can also set a scallop height, with either it be constant or not as well if needed. In this case I've used 2mm. From there we can go save and calculate and see what the toolpath brings to us. What you'll see is that we go to 2 depths for our iMachining strategy, and then we rough the stock upwards in a rest roughing strategy to get the shape that's required within 3D. Using the SolidCAM simulator, we can exactly see what is being machined and either take into account the fixture that's holding this part. So if you've got even more complicated fixturing, this can be accounted for as well, allowing us to have complete confidence in what we're machining. With the end of this toolpath, this completes the end of our introduction into iMachining, and I hope you've enjoyed it.